You'll also have a couple problems that involve solving by factoring, and I wanted to show you how to do those. So if I solve by factoring, the first thing I'm going to do is I'm going to recognize that it's a squared problem, so it's quadratic, so I'm going to make it equal to 0. So 2 sine x plus sine x minus 1 equals 0. Now for some students, it helps them to think of this as 2m squared plus m minus 1 equals 0, to think about what it would look factored if it didn't have all those trig functions in it. Like this would be, has to multiply a negative 1, so 1 and 1, and the 2 has to be positive, so outside's positive, inside's negative. So this might be an intermediary step if you have trouble seeing things with sines and cosine. But for some people, they can go straight to, that's 2 sine x times sine x. That gets sine squared x. And then 1 times 1, and this one has to be positive, and that one has to be negative. So now remember, when you're solving a quadratic, either one can be true. So this could be that 2 sine x minus 1 equals 0, or sine x plus 1 is equal to 0. And then, like in any quadratic, you have to make both parts equal to 0. So the first part will be sine of x is equal to negative 1. Remember, your sine is your y value, and your y value is negative 1 down here at 270 degrees. And so this is going to be one solution, x is equal to 3 pi over 2. And that's actually the only place on the unit circle where the sine is equal to negative 1. We also have the second piece where 2 sine x equals 1, and so sine of x equals 2 1/2. And that actually occurs at two different places on the unit circle, and that is at x equals 30 degrees, which is pi over 6, and at x equals 150 degrees, which is 5 pi over 6. And this will lead into a different discussion. I think I'm going to need a second page to show this. So, if the question had limited our domain to the unit circle, like all of our answers had to be between 0 and 2 pi, then my answer that said x was equal to 30 degrees, pi over 6, or 150, 5 pi over 6, or 3 pi over 2, that would be our solution. But if there was no limit to the domain, then all of those answers, like this 30-degree answer, it would happen here at 30. It would happen again at 390. It would happen again if you had another 360 at 750. And it will repeat over and over again. So if your domain is not limited, then your answer will be x is equal to pi over 6 plus 360 n, or actually, let me keep with the same units, 2 pi n, where n is an integer, and 5 pi over 6 plus 2 pi n, where n is an integer, and 3 pi over 2 plus 2 pi n, where n is an integer. And so this is just sort of a notation saying that these values are going to repeat every 2 pi because the period's 2 pi, and obviously if it was tangent or cotangent, it would repeat every pi. Let's do one more of these problems. So this says when is cosine over cotangent equal to 1/2? So the first thing you do is work on simplifying the left-hand side, and so I'm going to write this as cosine x divided by, make this a big fraction bar. The bottom is cosine x over sine x, because that's how and that's actually using the first strategy, rewrite everything in terms of sine and cosine. And now I'm going to flip the second number and multiply. So this is cosine of x times sine of x over cosine of x. Cosines cancel, so that's sine of x. When is sine 1/2? Well, we know that's 30 degrees. Ooh, and it's also 150 degrees. So if it told you that the domain of the function was between 0 and pi over 2, then your answer would be 30 degrees. If it told you the domain of the function was between 0 and 2 pi, then your answer could be pi over 6 or 5 pi over 6. But if it told you your domain was all real numbers, then your answer is going to be pi over 6 or 5 pi over 6 plus 2 pi n, where n is an integer, and so both those answers keep repeating to infinity every 2 pi times the integers.